Hi, Torsten Grust, back on stage here to continue our discussion of MonetDB and mal and the buts and the internals of the RAM-based MonetDB database system. Okay. So when you translate or want to execute a SQL query in MonetDB, recall that the system internally converts the query into a MonetDB assembly language program or a mal program. If you recall the program from the last video for our ProQuery Q1, you will recall that it probably looked like this. I've beautified, shortened, and formatted the relevant parts of this mal program for you. But this is the relevant part of mal statements that actually implements the logic, the mal logic, to evaluate the ProQuery Q1. It's, of course, a sequence of assignment statements to mal variables. This first assignment statement actually initializes MonetDB internal transaction management. What transactions are and how they are really super relevant to the operation of such relational database systems is something that we will turn to towards the end of the course. But for now, let's view this as a sort of initialization for the SQL subsystem of MonetDB. And what we get here is some sort of SQL handler or SQL identifier that we pass to further mal functions if we want to operate on SQL tables. So such a SQL table like table unary, how would that be represented internally using buts only? And we can see that here in the columns, in the rows 2 and 3 of this mal program. You see that we are assigning two buts here, the unary but and the a but. These are variable names I have picked randomly, but these are two buts, one of OIDs and one of actually integers that are used to represent the SQL table unary. So the one column, the single column SQL table unary is internally represented using two buts, one but of OIDs only and one but of integers, the actual payload. And then later on, the mal program operates on these two buts, on the unary and the a but. You see that here in the row 4 to compute the actual result of the query. But before we do that, let's have a look at what we actually get if we talk to the SQL level of MonetDB from the mal level of the system. So let's switch back to the terminal here. There we are. Okay, so let's replay what we've just seen on the slides. Initialize the SQL subsystem of MonetDB so that the mal level can talk to the SQL level. Done that. Okay, and then access one of the buts, one of the two buts that are used to represent the unary table that we've defined in SQL. So we will access the A column that has been defined for this unary table, and we will copy it into the mal level, assigning it to this mal variable A here. So let's do that. Okay, so in this but A, we have now the contents of the SQL column A, the A column of unary table. Let's see what we can find in this but A. Okay, we can find the payload of all the integer values. Here's integer value 95, one of the values that we've stored in this integer column of table unary. And we find all the payload there. All the integer values have been stored there, starting from 1 going up to 100. And these are stored in a but with offsets, with virtual OID offsets, with a head column starting at 0, 1, 2, 3. So for example, the A value 3 is stored at offset 2 inside this but that is used to represent the column A of the SQL table unary. Okay, so we have a representation of the SQL column on the MAL level. And that's, of course, why it's being accessed in this MAL program, because probe query Q1 asks for the contents of the A column. And no wonder, no surprise, that the MAL program will access the particular SQL column A and bind it to this A but. But this is not all that's happening here. We also access this unary but and then perform some computation here. And the reason for that is given here below in the comments. The unary but is used to compute or used to extract the rows of the SQL table that at a particular point in time, at this point in time, are actually visible to the application or to the user. Rows may become invisible once they get deleted using a SQL delete from command, for example. Okay, so this is the payload of the integer column. This but, the unary but, actually gives us information about which of these integer values are currently visible to the user or to the application. Okay, some of them might have been deleted. That information is only visible and or is only being reflected in this unary but. Okay, so to restrict our result, the output that we are generating, to the only to the visible A values, we use this algebra projection mal function to apply, to extract, to restrict the A values, the 100 A values that we have extracted to the actually visible values. I've brought another slide with me to make this more clear. This is the algebra projection operation. It takes two arguments, two buts. This is the first but, this is the second but. Okay, the first but is the unary but. It defines the visibility of rows. The second but is the A but that we've just seen in the MonetDB M client terminal. It contains the 100 payload integer values that we've defined. The unary but defines visibility, and as the slide says, assume that somebody has deleted, using a delete from command in SQL, for example, somebody has deleted the row carrying the A value 3. This was stored at OID2, as we have seen in the M client console before. That's why in the unary but you see that it only carries 99 rows. And the row with offset 2, the row with offset 2, which has been deleted before, as we are assuming here, is actually not present here. The OID2 is missing, representing the fact that that row should indeed be invisible to the user or to the application. Now what the algebra projection command will do, it will scan the tail values in this first but. Finding a 0 means that, okay, the 0th row at offset 0 in the second but is actually visible and should be copied into the result. So let's do that. Row 1 is visible. Okay, so let's copy it down to the result. Row 3 is visible. Okay, so let's copy it into the result. And you see that row 2 containing the deleted A value 3 has not been copied into the result. The result, of course, has only 99 rows, 99 values. The A value A equals 3 has been missing, just as we are expecting it if it has been deleted from the table unary. And that's one example of how mal commands are being used to implement the SQL semantics. In this case, using the algebra projection function of mal, and we will get to know a whole lot more of these mal functions and their really very simple operations over buts in the course of the lecture. Okay, but this is just a first taste of how mal internally looks and tastes. Okay, for more, stay tuned. See you soon. Bye bye.